For probability, we'll have a fraction for our answer. It'll be the chance of success, how many successes there are, divided by how many possible outcomes. First problem, we'll have probability of rolling a 5 on a 6-sided die. Success would be a 5. There's a single 5 on a 6-sided die, so there's one chance of success. And the number of outcomes, or how many numbers are possible. On a 6-sided die, there would be 6 sides, so you have a 1 out of 6 chance of rolling a 5. Second question, and last question for the section, the probability of tails on a coin flip. On a coin, there is one tails, one side has tails, and a coin has 2 sides, so the probability of tails would be 1/2 or 1/2. For this problem, we'll be using combinations. When Bob reaches into the box and picks out 3 football cards, or 3 cards that he wants to be football, we're doing multiple events. Combinations will be for multiple events, which the order does not matter. It does not matter which football card he pulls out first, just as long as he pulls out 3 football cards. Probability again will be a fraction. If we do the numerator, the chance of success, we'll have a combination for the football cards. The first number is the total number of football cards, which would be 8. And the second number is how many we're selecting, or how many we want. In this case, it would be 3. So combination 8, 3 tells you how many successes, or how many different ways there are to pull out 3 football cards. For the denominator, we'll have another combination. This combination will be the total number of outcomes, again for all the cards. If you count up all the cards, there's 12 baseball, 8 football, and 5 basketball. Adding those together, there's 25 total cards. We want 3 football cards, so we're going to be picking out 3 cards. So we're going to find out the combination 25, 3, how many total ways there are to pick out 3 cards from this box of sports cards. Solving this, we have combination 8, 3. That would be 8 factorial divided by 8 minus 3 would be 5 factorial. And also the combination has the 3 factorial on the denominator. Our second fraction will be for our second denominator will be 25, 3 for the total combinations. And that would be 25 factorial divided by 25 minus 3 would be 22 factorial. And the extra 3 factorial goes on the end. Simplifying this out, 8 factorial would be 8 times 7 times 6, all the way down to 1. 5 factorial would be 5 down to 1. And 3 factorial would be 3 down to 1. For the bottom fraction, we'll have 25 multiplied down to 1. What I'll do in this case is I'll go down to 22, and I'll put ... times to 1. That's because we'll be crossing these numbers off in just a minute. For the denominator, we'll have 22 factorial. And again, I'll do 22, 21, and I'll put ... times to 1. So we'll have all the numbers from 21 to 1 in there. And again, we'll cross those off in just a minute. 3 factorial would be 3, 2, and 1. Simplifying this, we have 5 through 1 we can cross off for the numerator of this fraction. 3 times 2 would be 6, so we can actually cross off the 3, the 2, and the 6. And the 1 again we can ignore, so we're left with 8 times 7 for the top, which would be 56 for a numerator. For the denominator part of the fraction, we have 22 to 1 on the top of the fraction and 22 to 1 on the denominator of that fraction, so those will cancel. We have 3 times 2, which would be 6, so if we divide by 6, this 24 we can divide by 6 and we'll be left with a 4. So we'll have 25 times 4 times 23. If you multiply those out, that comes out to 2300, which is how many possible ways you can pick out 3 cards from this box. Our final answer, we can reduce this fraction. Dividing by 4 would give us 14 over 575. So for this question, Bob wants 3 football cards. He has a 14 out of 575 chance to get 3 football cards if he randomly picks out 3 cards. Next question we'll do for that same problem with the box of sport cards will be the probability of picking 1 basketball card and 2 football cards. Again, if we're doing multiple events and the order does not matter, it doesn't matter if we pick basketball and football or football then basketball, we'll be doing combinations. If we do basketball first, it'll be combination. The first number is the total number of basketball cards. Looking back at the word problem, that would be 5, and we want to choose one of those. The second event we'll multiply by to find out the total number of ways to get basketball and football would be combination. The football cards, there are 8 total, and we want to pick out 2 of those. So for the number of successes for 1 basketball and 2 football cards, we can find the 2 combinations and multiply those together. For the denominator, we'll have combination. There's 25 cards total in the box, and we're picking out 3 total cards. One shortcut we can use, that previous question we actually solved, combination 25, 3, and that was equal to 2300. Solving combination 5, 1, that would be 5 factorial, divided by 5 minus 1 would be 4 factorial, and 1 factorial. And then we're going to multiply that by 8, 2, which would be 8 factorial, divided by 8 minus 2, which is 6 factorial, and the last number, which is 2 factorial. Solving this out, 5 factorial would be 5, 4, 3, 2, and 1. And 4 factorial would be 4, 3, 2, 1. 1 factorial would just be 1. 8 factorial would be 8 down to 1. 6 factorial would be 6 down to 1. And 2 factorial would be 2 and 1. Crossing off what's in common, 4, 3, 2, 1 on the first fraction cancels. 6 through 1 also cancels. The 1 on the first fraction we can ignore, and the 2, we can divide the 8 by 2 to get 4. So we're left with 5 in the first fraction, and we have 4 times 7, which is 28 in the second fraction. Multiplying that out, and that gives us 140 for the numerator. Again, combination 25, 3 we solved in the previous problem was 2300. Reducing this, you can divide each of these by 20, and your final answer would be 7 over 115. And again, if Bob wants to pick out 1 basketball and 2 football cards, he has a 7 out of 115 chance to do so.